Hello everyone and welcome to the 10th Raspberry Pi tutorial. Just before I start, I'd like to say a massive thank you to everyone who's subscribed. I've got 721 subscribers now and just over 30,000 video views, which is fantastic. I've not been able to do that much today because I'm pretty busy at the moment with college and stuff like that. I've got exams to revise for, and we've started back after Christmas now. So, as well as doing these tutorials, I've got computing coursework that I need to do. So I need to do software for that, and I've also got my own software that I'm working on as well. So that's quite a lot of things I've got to juggle. So, just wait for this to load up. But yeah, it's called, the tutorial's called Feeding PiSnake because what I've done today is I've made the food class. So basically, I'll show you what it does. But basically the food class draws a little tiny Raspberry Pi logo, as you can see there, somewhere random on the screen. So what we'll have so say the mouse is the snake. We'll have the snake coming down here, controlled by the arrows, and then when it eats that, the snake will get bigger, and then this will move somewhere else random. So if we run this again, you'll see that it's in a different place. So it's in a random position. Nothing really else in the main code has changed apart from a couple of little bits. So I'll run through the food class first. Okay. So the food class inherits pygame.sprite again, and the reason for that is if we inherit sprite, then it allows us to put that into groups. So if I go into the into PiSnake main, and here we've got so we make our self.food, and then what we do is get our food into a sprite collection so we can easily update it. So what you can have is in this collection, if we wanted 2 or 3, which we probably won't in this case, but still it's good practice. So we have a sprite collection called sprites, and then we put food into that, and then when we're actually in our main loop, all you have to do is say self.sprites.update and then self.sprites.draw and pass through a screen. And if you look here, here's our update function, and it's pretty simple. Every sprite has to have an update function, and that's whatever runs when you run on that on the group collection of sprites. So I'll run through this anyway. So we're passing through a screen rectangle, so we know how big the screen is. We've also got a variable called eaten, which is set to false. And what's going to happen is when that's set to true, which will happen when the snake comes, when the snake collides with that's going to get set to true, and then this will happen. So if self.eaten is true, then we'll get a random position. So that should actually be self.random position. Obviously I've not tested that because we haven't got a snake yet, so it'll never be set to true. And then self.eaten will go back to false again. False with a capital F. So yeah, but let's have a look at the main bit of code. So we've got image file holds the location of our image. We then set self.image to that image, to a converted version of that image to a Pygame surface by doing convert alpha, and then we get the rectangle from that image. And then this is the important bit really of the food class. So we set ourselves to a random position which runs this, and what we have to do is we have to have a random number generator for the x and the y coordinate, but you have to give that a range to make sure that it doesn't go outside the coordinates of the screen. So it says here, workout ranges so the rectangle's always on the screen. We are assigning to the right side so it can't be less than the width, and the M range is the edge of the screen. So if you think about it, the right side of a rectangle, so the minimum point has to be the width of that rectangle so it's on the screen. And then the M range can be anything, so that's just the width of the screen. And then it's a similar thing for the Y. And then here, this is just set the X coordinate of the top to a random value. So yeah, that happens there. So let's see what have I changed in the another thing I've changed is instead of the background class saying saying PiSnake.screen.blit, I've passed through the screen instead, because that's the way the sprite class wants you to do it. So I assume that's the best way to do it. And the only other bits that have changed are some little bits in the main loop. So as before, we initialize pygame. Something I've put in here is I've created a clock to manage the time, and that's so we're not using 100% CPU time in this while loop here. So we do self.clock.tick, and then we put like 20, so that means like 20 ticks a second, or 20 frames a second. This is the same. Oh, that's the same. I've also put like a get screen rectangle in here, just so that can be passed through to the food class, for like a reference of where it should position itself. I've also moved the creation of background class out of the main loop, where it shouldn't have been, into this initializer. So then in the main loop we're just calling background.draw, whereas last time we were making an instance of background every time, and although that works, it'd be bad for performance. So then we make a food class passing through the screen rectangle, and we get our food sprite into a sprite collection, and that's so we can update it, like as I'll show you just below here. So that's that bit done. That's the initializer, so I'll just minimize that. And the only bits that have changed in the actual main loop really are this clock tick, so limit the frame rate, and just this sprite update bit. So update and draw our sprite, so we just do self.sprites.update, which calls the update function in every sprite we have, and then that just draws all them sprites to the screen, and that's it. So what we get is we just get a little Raspberry Pi logo that draws itself at a random place on the screen, which will eventually become the food for our snake when we have it. But yeah, thank you very much for watching, and I'll see you next week. Cheers.